Greetings. Today, let us discuss projection of solids, in which today's solid is square pyramids. Here we have example problem number 16. A square pyramid, 35 mm sides of base and 65 mm axis length, rest on HP on one of its edges of the base, which is inclined to VP at 30 degree. Draw the projection of the pyramid when the axis is inclined to HP at 45 degree. So the xy line is drawn, the above xy line is VP, and below xy line is HP, that is horizontal plane. Since the solid is rest on HP on one of its edges of the base, let us draw the edge condition. The square is continuous line, thick line. The square is of side 35 mm, so width 35 and height 35, and angle 0. So for pyramid, we can see the slant edges. So join the slant opposite corners to represent the slant edges. Let us call this as A, B, C, and D, the apex as O, and base center as O1. The projection of this will be taken to front view till XY line. Then the projection of this intersection apex till XY line, then followed by an axis line which represents the height of the pyramid 65 mm 90 degree. Then change the line type to continuous line. Join the front view. The front view of the pyramid is going to be triangle. So in front view we can see apex O dash. Here the corner B dash is visible and A dash is going to be invisible. The base center O1 dash is going to be invisible. C dash is visible, whereas the D dash is going to be invisible. Now the axis is inclined to HP 45 degrees given. Let us copy this using move command, modifying command. From this C, I'll place it to the second position. Then I rotate the same with respect to base. Since axis is inclined 45 degree to HP, so base is also inclined 45 degree to HP. 90 minus 45, we get 45 degree. Let's go for dimension. The angle between the axis and HP is 45 degree. Then the height of the pyramid is 65 mm. The side length is 35 mm. Let's go for projection. 0.13 mm thickness line. So this is AB line. So projection of A will come till here, and projection of B is of here. Then projection of C and D will come on this line. Projection of O will be till this apex O. Then if you take a horizontal projection line, these are the horizontal projection line we can take. Now let us go to visible edges. The outermost edges of the solid is visible. So these are the outermost edges of the solid. And if you see from top, the OA and OB are visible. Let us call the name first. This is O. So this is going to be A, B, C, and D. So OA and OB will be visible from top. So join this OA by a visible line, by a thick line. Then the resting edge is always going to be invisible. So it's resting on C and D, going to be invisible. Let's take projection of axis. O1 is here, and this is the projection of axis. So show the axis O to O1, and that O1 is going to be invisible. O1 is invisible. Okay, so now the third condition is the resting edge, the edge on which the solid rests, is inclined to VP at 30 degree. So take a construction line, 0.13 thickness line, and give the angle between these two 45 degree. Sorry, yeah, 45 degree, 30 degree to VP, 30 degree to VP. Now make use of modifying command called move. Move this solid with respect to point D on 30 degree line, then immediately rotate in such a way that the D and C will come on this 30 degree line. Then take the projection 0.13 mm line, projection of A will be till this endpoint, join it to this, then B is also coming on same line, C projection will be till XY line, D projection will be till XY line. O projection line will be here. So let me fix the angle 90 degree. So this is the projection of O dash, and O1 projection will be till here. So now this will be O dash, this is going to be A dash, B dash, C dash, and D dash. Since base is nearer to observer, the base is going to be visible. So take thick line, join A, B, this C projection C, D back to A, and the outermost edges of the solids are visible. So OB, OA, and OC edges are visible. Then take axis O1 to O is going to be the axis line, and that should be thin, so thickness is 0.13, and this is O1 dash is going to be visible in front tube, but the edge OD is very far away from the observer and is going to be invisible. So use dashed line to represent the invisible edge. So this is the solution for problem number 16. With this, let us move on to the next problem, example problem 19. So here is a similar kind of problem number 16, because if you read the problem, a square pyramid 30 mm base and 65 mm axis length rest on HP on one of its edges of the base. That means the previous problem what we dealt, the first position is going to be same. Draw the projection of the pyramid when axis is inclined to HP at 45 degree. So here also the axis is going to be inclined to HP at an angle 45 degree. So the first two positions are going to be same, but here the axis is inclined to VP at 30 degree. So in previous problem, the edge on which it was resting is inclined at an angle 30 degree. So I'll make use of this first two positions data. First two positions are same. Here what happens in the third position, the axis is going to be inclined at an angle 30 degree. The axis is already inclined to HP at an angle 45 degree. So axis inclined to both HP and VP means a line is inclined to both HP and VP means we need to find the apparent angle, apparent inclination, for which we need to construct locus. So let us first take the true angle, that is 30 degree to VP. Then to construct locus, take the arc by center point method. The original length of the axis is 65 mm. Cut an arc, then draw the horizontal line at the intersection of this arc and 30-degree line. Then measure the distance between O and O1, that is the apparent length of the axis. 45.96 is the value. So keeping at the same center, take radius apparent length of the axis, cut another arc. Then join this to the same center and measure that apparent angle. That apparent angle is 45 degree we are getting. Now we need to move the second position top view what we have in such a way that this O will coincide at this point, and rotate in such a way that this. So instead of selecting like this, I'll go for select tool and select entire thing, and here the construction of the locus need not to rotate, should be there itself. I'll deselect those things, rotate such a way that O1 will come on this apparent angle 45 degree line. Then we need to take projection line thickness is 0.13. A projection of A will be till here, projection of B is also comes on same line, C will be until XY line, D also till XY line, O and O dash projection will be taken, and finally O1 projection will be taken here. So let us call the corners. This is O dash, this is going to be A dash, B dash, C dash, and D dash. So since base is nearer to the observer, the base is going to be visible. A, B, C, D, back to A. Then outermost edges of the solids are going to be visible, whereas the OD is going to be invisible. O dash D dash is going to be invisible edge, will be represented by dashed line. Then let us show the axis line by thin line O to O dash, O1 dash to O dash, and O1 dash is going to be visible in front view. So this is the solution for example problem number 19. Let us move on to the next problem. Example problem number 18. Here a square pyramid 35 mm sides of base and 60 mm axis length rest on HP on one of its corners of the base, such that the two base edges containing the corner on which it rests makes equal inclination with HP. Draw the projection of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and to VP at 30 degree. So here the square pyramid of side 35 mm is going to be rest on one of its corners of the base. So I need to take the corner condition of square, and this should be visible line and thick enough. Then join the opposite corners to find the slant edges. Then the projection line I need to take. Before that, I call the name A, B, C, D for these corners, then O for apex and O1 for the base center. Then the projection of this A will be till xy line, B and D will be here itself, C will be here. Then let us move on to the axis. From here, the height axis length is 60 mm, 90 degree. Then let us move on to the visible line. The outermost edges of the solids are going to be visible. And this BO, the slant edge is going to be visible. So this is O dash, the A dash, B dash in the bracket, D dash. Also here itself comes the O1 dash. Then C dash. We do the dimensioning, 35 mm sides and 60 mm axis length. The axis is inclined 40 degree to HP, so for which I make use of the first position front view. Use modifying command move with copy on, move from here to here. Then rotate the same in such a way that the base is inclined. Since the axis is inclined 40 degree to HP, base will be inclined 50 degree to HP. That is 90 minus 40 is equal to 50. Let us measure the angle between these two. That is 40 degree is the right what we had taken. Let's go for projection. So this is A, projection of A, projection of B, then projection of C will be till here. Then projection of O will also come on. F6 minus 90 degree. Then if you take horizontal projection, D over here. Now let us take a thick line to find the visible corners, visible edges. The outermost edges of the solid is going to be visible. And if you look from top, O dash A dash is going to be visible. So join O dash A dash. Since the base edge O, CB and CD is going to be invisible. So this C, D and C, B is going to be invisible. Let's call the name A, B. Here the corner C is going to be invisible, and corner D, O, and the base center, that is O1, also is going to be invisible. The axis line we need to show between O and O1. This is the axis line. Since the visible line is overlapping on axis line, is not the visible line is going to be visible, not the axis line. So VP, the axis is inclined to VP at 30 degree. So let us take 30 degree line, construction line. Since axis is inclined to both HP and VP, we need to construct the apparent angle. We need to construct locus and find apparent angle. The original height of the pyramid is 60. By taking arc by center point method, 60 is the radius to draw an arc. Then draw a horizontal line. Determine the distance between this OO1, the apparent length of the axis, 45.96. So take same arc by center point method by measuring from same center, 45.96 the radius, cut an arc. Then join this with the center measure the apparent angle. The apparent angle is 41 degree. Now with this data, let us move the second position top view using move command such a way that O will be at this end point and rotate in such a way that O01 will come on this 41 degree line. Then projection of A and A dash and projection of B and B dash. C will be till XY line. D back to O. Then since base is nearer to observer, the base is going to be visible. This is A, B, C and back to B, and the outermost edges of the pyramid is going to be visible. If I call the names, this is going to be O dash. Here we have A dash, B dash is standing on C dash and D dash. So the edge D to O is going to be invisible. Then take projection line. So this should be continuous line. Now the axis, this is visible line. So let us go for axis line from here to O, and this gives O1 dash. So O1 dash is visible. So this is a solution for problem number 18. Axis inclined to both HP and VP. We move on to problem number 17. Here it's almost similar to problem number 18. The all data are same, but with minor changes. That is, it also rests on one of its corner of the base. Hence the first position is same, and axis inclined to HP 40 degree. Hence the second position also same, but and the axis appears to be inclined to VP at 45 degree. That is the last sentence is mentioned in blue color. There are the changes we need to do. There is appears to be inclined to VP means the apparent angle itself 45 degree. So we need not to construct the locus. To just minimize the time, I'll make use of this same data. Instead of constructing the locus, we need to go for construction of apparent angle directly, that is 45 degree line. So on this 45 degree line, yeah, this is 45 degree line. We need to move this second position top view such a way that O1 let lie on 45 degree line, then rotate the same. This should come on 45 degree line. Then take projection line 0.13. A will be till here. B C will be till XY line, and D. O. Projection of O dash. So here also the base is going to be visible, hence the base edges are going to be visible. So this is projection of A, B, C and D, and outermost edges OA, OB and some portion of OC also visible, but the OD is going to be invisible. So if we call the names, this is O dash, A dash, B dash, standing on C dash, and D dash. Take the projection line of the O1 also. The line O1 is 45.96. Here the end point is getting at this end point. Then let's move on to the axis line from this end point to O. Since the base is visible, the O1 dash also visible. So this is a solution for example problem number 18. So by this we completed example number 16, 17, 18, 19. I hope you understood. Thank you.